So the next factor of temperature is winds. So the effect of the prevailing winds is limited to the period during which they blow. Winds which come from the warmer areas increase the temperature of the region over which they blow, and the winds that come from the cooler areas lower or decrease the temperature of the areas over which they blow. For example, the warm dry Chinook winds, which is a local wind which blow from the Rocky Mountains, melt the snow over the prairies, while the cold winds which blows from the polar regions decrease the temperature in the northern parts of China. The next is slope of the land. So the effect of slope is very prominent in the mountainous regions. The mountain slopes which face the sun receive more insolation. It means the incoming solar energy as direct sun rays fall on them. Thus, in the northern hemisphere, the south facing slopes are warmer than the north facing slopes. For example, in the northern hemisphere, the valleys located in the southern slopes of the Himalayas and the Alps are warmer and have more human settlements than the north facing slopes. The next is ocean currents. Remember, there are two types of ocean current. The one is warm ocean current, another one is cold ocean current. So these warm and cold ocean currents affect the temperature and climate of the places along which they flow. So the winds which blow from sea to land and pass over warm water currents tend to increase the air temperature in the coastal areas. Also, it causes rainfall, while winds which pass over the cold water currents tend to decrease the temperature and create dry conditions. For example, cold Labrador current that flows from the Arctic southward along the Labrador coast keeps the east coast of Canada cold and ice bound for 9 months. Okay, whereas the warm ocean current that is called the North Atlantic drift keeps the coastal areas of northwestern Europe warm, although both of these places are situated on the same latitude. That is the significance of ocean currents. Next is cloud covered. So the amount of solar radiation reaching the earth's surface and the amount of terrestrial radiation leaving the earth's surface are affected by both, that is extent of cloud cover. The presence of clouds during the day reduces the insolation reaching the earth. On a cloudy night, the terrestrial radiation is prevented from escaping the earth's surface and raises the night temperature of the earth. That is why you see the on the cloudy summer night the weather becomes quite uncomfortable. So our next topic is atmospheric pressure. So it is the force exerted by a column of air due to its weight over a unit area of 1 square centimeter on the earth's surface. The movement of air is related to air pressure. The bar is now the standard unit of measurement of air pressure. Now this atmospheric pressure is measured by an instrument that we call it barometer. There are two types of barometer. One is 14's barometer, another one is aneroid barometer. 14 barometer is also known as mercury barometer. Now atmospheric pressure depends on the following factors. What are these? Altitude, temperature, water vapor and the rotation of the earth. So now in this part we will learn the factors of atmospheric pressure. The first is altitude. So the places at greater heights experience less pressure compared to places located at a lower altitude. Air pressure is the highest at the sea level and decreases with altitude. So in the higher altitudes the air is very thin and there is less insufficient oxygen in the air. So the density of air decreases with altitude and the pressure exerted by it also decreases. So the temperature falls by 1 degree Celsius for every 165 meter of ascent. Earlier you learned about the normal lapse rate. Next is temperature. So when the temperature increases, the volume of air expands and its density decreases. This leads to a decrease in the air pressure of that area. On the other hand, when temperature decreases, the air gets cooled. Its volume contracts and become dense as the molecules in it are closely spaced. So, therefore, cold air becomes heavy and descends. This leads to the formation of high pressure. The next is water vapor. Air which contains moisture is lighter than dry air. Therefore, moist air exerts less pressure than the dry air. Presence of water vapor in the air expands the volume and decreases the density. Hence, moist air always ascends. The last factor is rotation of the earth. Now, what happened is that due to rotation, the air rising above the equator is pushed towards the pole and moves in the upper troposphere. This air starts to contract as it cools and starts to subside at 30° north and south. The speed of rotation at the poles is slow and the air is thrown outwards from the pole towards the equator. That is the reason of this dynamic motion of the earth. Rotation has caused the formation of a low pressure belt at 60° north and south of the equator and a high pressure belt at 30° north and south of the equator. Although we will learn about these pressure belts in detail in our next topic.